So in the previous sessions, we have started our discussions on basically control flows in which we studied branching. That is the conditionals. If some condition is met, we want to branch, and then we start with the iterations, or we call them loops. So in which we want to repeatedly do some tasks. So in that, we start with the for loop. So what is the main job of the loop? The job of loop was if you want to do something again and again. So I showed an example. The example one, let's suppose you want to print something. If you want to print something, let's suppose 3 times. You can write print hello, print hello, print hello. But what if you want to print it million times? Then it becomes very difficult. So you'll have to have a programming structure or programming way of printing that thing a million times or maybe a billion times, howsoever you want to try it. And for that, we have these loop mechanisms. So for the in that we started with for loop. So this is the first loop. The syntax I showed you, that is we have this for, and then we have iterator, and then we have this keyword in. So this in is the keyword, and then we wrote an iterable. Okay, and then we executed the statements over here. And but necessary is that you should put colon and you should care about these indentations. This is very important. Okay, if you do not indent it properly, then it won't be called as a block of for. So whatever is indented in the for is called as for block or block of the for. So you have to take care of this. I hope that we're discussing about this iterables iterator. So in that we used, okay, if we have a list, how to iterate in the list. If we have, let's suppose, a tuple, if you have a dictionary, we learned how to basically iterate through all of these things. Okay, and after that, I also showed a way of iterating in a range, because this should be an iterable. Now, if you want to print some, let's suppose you want to do something 3 times. So what you can do is you can write in the code for I in, let's suppose, 0, 1, comma 2, and then you can print something over here. Okay, print hello. Let's go to the code so that I'll show you in the code. So we had this way of doing the things, but the better way should have been, actually we wrote the range function. So let's go there. So here, if you see the test, so what I'll do is, if I create a list for, let's suppose, I in, I'll create a list 0, 1, 2. So it contains 3 elements. So now if I want to print something 3 times, so this is how I want to do it. So this is hello. I'll just this is Python, run the program, Python test.py. So if you see, hello was printed 3 times on the screen. Okay, that is pretty clear here. So now, if I have to print a million numbers here, then it becomes difficult, because we have to write million entries in here, because this I is the iterable and this list is the iterator. So the better function, or better way of, or we call it Pythonic way of doing it. Okay, so how Python makes it easy, we write range function. Okay, so this was the range, and then we had the start index, and we'll start it from 0, and then we have end index, and we'll start, let's suppose we want to print 10 times, and then we have the step size. Okay, step size is how many numbers should it jump. So by default it's 1, so we'll keep it 1. But if we don't write anything, it's by default, it will take the default parameter. So now if I run it, so you can see that hello got printed 10 times. So this was the range function that we studied in the for loop. Now we can also have the nesting of these loops. We can nest one loop within the other. Okay, so that's called the nesting of the loops. So in the previous session, we also have discussed about nesting of these branching statements. So here, what we can do is we can nest these for loops also. So if you want, you can have a for loop within other for loop. So let's do that also. Okay, so what's the nesting of for loops? So let me just first write nesting the for loop. So here, what is nesting of for loops? Or maybe nesting of loops. Yes, we can loop the while loop also. So nesting of loops is if you write one loop within the other. So let's suppose you have this for, okay, and then there is something, then you write for within that for, and you can execute some statements over here, you can execute some statements over here. So why necessary? Sometimes you want to iterate multiple in a multiple way. Let's suppose you have a matrix like this, okay, and you want to iterate row wise, okay, or all the elements. So you can use two for loops. So best classic example is if you are creating some game or something like that. In that, let's suppose you want to create a square structure like this, some square structure, 3 by 3 square structure. What you can do is you can use these nested for loops. So okay, let's dissect this for loops, nested for loops, and then we'll probably see what can be achieved with that. So now what I want to do is, the first thing is, let's suppose I want to print a square on the screen, because if you work with the graphics, there you will have these building blocks. So here, let's suppose this hash is a building block. So if I want to print, let's suppose, this hash on the screen, so the simple way is just you can write, let me not just cancel, I'll just comment this code out so that it remains a record. Let's suppose I want to print this hash. So how I can do it? I can print, and I can print this hash symbol over here. Okay, this is my hash symbol. If I just want to see how it looks, so this is the way. So this is how I print one hash on the screen. So let's suppose I want to print a square. So there are different ways to do this, because you know now I have to repeat. If I want to print, I can print like this, hash hash hash. Okay, then probably go down and print something like this. But still it will print in one line. Okay, and this is the multi comment now. Let's put it. Let's write. Let's suppose 3 strings, and we'll close it by 3 strings also. Let's first test with this. Okay, what will happen? So if you see, you saw this is what it got printed. So if I want print it like a square, so I can do it like this. Okay, again copy this. This is one way of the code, but you saw how tedious this is to write. Okay, in a game, let's suppose if you have seen different game, and I'll have to adjust these lengths so that it looks similar on this. So you can see a mess gets created. So better to use, because you know now I'm repeating these hashes. Okay, so if you see on the screen, so these hashes are getting repeated. These hashes are getting repeated. So better way of doing this is by using the loops. So what I can do is I can use a nesting of the loop. So by nesting, I mean how I'll write this. So I'll write it like this. So I'll write for, let's suppose I want first 3 by 3 hash I want. Let's suppose I'll write for I in a range of 3, and then again within this loop I'll again create one more loop for j in range of 3, and then I'll print hash. Okay, now do tell me, I don't expect the answer to be right as 3 by 3, because we did some mistake. I want you to point out that mistake. If I run this code, you can see the hash got printed, but it got printed on the like column wise. It was not printed as we wanted it to be. We wanted to be printed like a square. So can you debug the code? Can you tell me what went wrong?
I think, yeah,
Yes.
print, at the print unit, we need to add the break. We need to remove the break.
I haven't wrote the break somewhere.
Print automatically adds the line and, I mean, the line break. So after the inner
So
loop,
yes. What should we do then?
we should add the end is equal to maybe
Yes. And
double.
is equal to just this. And if you see, still I don't expect an answer like that, because I know there is a mistake. Let's check it. You see this now.
We need to print one line after every time inner loop gets executed 3 times. We need to print one line.
Yes. So we just need to just escape the characters. Okay. So let's do this now. If I just see the answer, you can see it now. So now this is a 3 by 3 grid. Okay, let's try to understand this code. Maybe there are people who don't understand this code. Okay, let's try to understand this. So if you see it over here, so I have this for I in range of 3. So what will it do is this range basically. So it will create an iterable in which we have the 0, 1, and 2. Okay, and then this I is taking that value, and then for range in, again I'm going in the inner loop. So for each value of I, so how should have you have the mental model? So you should have like this: I takes value 0. Let's slide it slightly better: 0, 1, and 2. Okay, that's what range does. It will give you three values: 0, 1, and 2. Now we have value j. So this is for the value I. Okay. Now we have this value j. For each of this value I, j will again take three values. If you see, it'll branch like this. It'll take 0, 1, and 2. And for this, it'll 0, 1, and 2. This will be 0, 1, and 2. Okay. For each of the values of I, j takes three values. That's why we call it a nested loop, because for each iteration of the I, j takes three iterations. So now if you see it, now all in all you can see this loop is running 9 times. This is first, second, 3, 4, 5, 6, 7, 8, and 9. So this runs 9 times. But now it was up to me how to basically print it on the screen. So if you see this print function over here, so once we had this hash only, so as you know that by I showed you the documentation of print, by default there is this escape character. Okay, so it takes the cursor to the next line. So when you print just first hash, it will take it to the next line. So that's why we added this end is equal to, inverted quotes. Basically override that backslash n with this. And after that, what happened is it just printed one row. But what I want is, once this print is that row of three hashes, I want the cursor to get down. So for that, that's the reason. If you see the indentation over here, so this print belongs to inside. Okay, this being inner loop basically. So this print is the part of inner loop. If you should see this print, I have just indented a little bit backwards. Okay, so this is not the part of the inner loop, rather it's the part of the outer loop, because first I want, for each iteration of the outer loop, inner loop should run 3 times, and it should print a row of hashes and then go back. Okay, so once I'm hash, hash, and hash, and then what should do, and cursor should come down, and then hash, 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 cursor should come down, hash, and hash. Okay, this is how nesting of the loops is done. Okay, now you can print different structures, and this is heavily used in the graphics. If you have seen those 2D games probably back in the eras of 2005 2006, so there used to be games in which we had these structures, 2D structures like rectangles, triangles, and even now if you see a game is there in the Chrome, there you have these you have a small bird which is flying here and there, and it changes these blocks can be rectangular, it can be square. So this is how it is done. Okay, so hash here I took a simplistic thing, hash. So but once you do the graphic maybe graphical visualization, so you will have complex structures in hash. But more or less, so what I wanted to get the point through is that how the nesting works. So for each of the outer loop we want the inner loop to run as many times. Okay, so that's why I showed you this tree sort of diagram. I hope this is clear for everyone. Let me pause here for a second, so that if there is a question I'll take that. The question that Mahmood asked is that once we let's suppose have this pattern, if you have to draw a pattern on the screen, so it becomes difficult how to draw this pattern. So this is a two-fold question basically. The first fold is that, let's just unhide. So we'll hide this. So what I'm saying is this is two-fold. So first you have to understand the structure itself. Understand the pattern. Okay, and then you must have an understanding of loop. Understand the loops, basically the nested loops. Okay, so if there is a pattern like this square, I showed you the square pattern, that's the easiest pattern, and then sometimes you will find a pattern like, let's suppose, this triangular pattern. In the first you will have like hash and then 2 hashes, or maybe 3 hashes we'll call, and then maybe 5 hashes. Okay, this makes a triangle. So if you see now, I see a pattern in this. So within a pattern I see a pattern. So in the first iteration 1 star gets printed. In the second iteration 3 stars get printed. In the third iteration 5 stars get printed. Now if you see odd number of stars get printed. So if I have to write the loop, so what I'm saying is, so for outer loop, so once the outer loop is run, okay, I have this I and j now. Now you can achieve this star pattern, you can achieve this triangular pattern by basically 2 loops. So the outer loop will keep track of which row are you printing. Okay, because now we are just printing these 2D designs, I'll say. We are printing these 2D patterns. So 2 loops will be end up. The first loop, the outer loop basically, the outer loop that we had in which we indexed that by I. So it will keep track of the rows. Okay, so which row is it printing. Then the inner loop takes care of how many stars or how many hashes do you want to print. Okay, so this is how you should think. First understand the pattern, so you understood there is a structure in the pattern. So in the first iteration I should print only 1 hash. In the second iteration I should print 3 hashes. So now this outer loop will keep track of the rows, and this inner loop, this will basically keep track of how many things do you want in a row. Okay, so how many in each row. So I think now the problem becomes pretty easy if you see it. So if I have to create a triangle, then what I have to do is I first should create hash, and then 3 hashes, then 5 hashes. Okay, and let's do it. Let's do it that way. Let's suppose I want to do this. Now if you see over here, so if you see in this, so for I in range of 3, I think it shows me the Google Meet. Oh, sorry for this. So what I'm telling you is, if you see the VS Code over here, I'll again bring up the VS Code. So if you see the VS Code here, so for the first iteration, so I'm always printing these 3 hashes. Okay, now what I should have a way, I should have a particular way. I don't want to give the answer right away. So now I just want you to look at this. So this outer loop basically is for the rows. So I'll just comment it out, hash. So this takes care of the rows. So let's suppose I'll write 4. So now you should see that 4 rows are getting printed. This is first row, this is second row, and this is third, and this is fourth row. So now this ascertains the fact that this is for the rows. If you write the outer loop, so basically for each of this I and then inner loop j, this gets printed. So now I want to see how many things do we want to get printed over here. Then you will have to manipulate this loop. Okay. Now here I am saying for j is equal 1, for j is equal j in range of 3, print 3. If I want to change this, now I have to do some tinkering inside, so that in the first iteration it should only print 1. So how to print that 1? Let's suppose I'll write I plus 1. Let's say I'll just experiment with it. I plus 1, because for I it will create, let's suppose for first it will create because I will be 0 initially. So inner loop will run 0 plus 1 one time. Let's do it and then see the pattern. So you see this like this. So 1 hash, 2 hashes, 3 hashes, 4 hashes. If I just want odd number of printing, so I can do plus 2, let's say. You can see structure like this. Okay, or I can just have odd number of hashes. But now if you see, this is a right angle triangle, so I'll just do it with 1. Now if you see over here, like keep an eye over here. So I'm saying for I in range 4. So this tells me I have to print 4 rows. So this inner thing will repeated 4 times. So what is inner loop taking care of? Inner loop is taking care of basically, so this loop. This inner loop is taking care of how many things do you want to print. So I have written for j in range of I plus 1. So I will initially 0. So this will, in the first iteration, this loop will inner loop will only run one time. That's why you'll see only one hash over here. If you see this, there's only one hash. So now once we are in the second iteration of this I is equal to 1. So this hash will get printed 2 times. That's why you see this 2 times and then 3 times. Now this is a right angular triangle if you see it. Okay, so there is right angle. So how to do this basically? How to basically shift this hash? Now you have an easy thing. You can just put spaces. Okay, if I again show you the structure, let's go there. So this is like this. So this is hash, but I want it to be like this, hash and then 2 hashes. Okay, then maybe 3 hashes, 1, 2 and 3, something like this. So now if you see a square, if you see it as a square, many people might find probably it like, why is sir again showing us to teach these patterns? Because now I'm teaching you how to basically think about these patterns. So if you see, I can fill the triangle this way. This is a square. So I can fill hash over here, hash, and then let's suppose hash, 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 hash. Okay, something like this. So you see a triangle over here. But now these are spaces. Okay, I know the how to create these rows. Now I'll do one thing. What I'll do is I'll first have 2 space. In the first row I'll have 2 space. In the second row I'll have 1 space. So the broader this triangle is, let's suppose, more number of, you have to now print basically 2 things. You have to print spaces and the hash so as to get the structure. So that's why I said this problem is twofold. The first, you have to understand the pattern. That's what I'm showing you. If you see this pattern like this, because now you see screen is just pixels. That's why I made this matrix. Screen is a bunch of pixels. Okay, consider this as pixels. Okay, then you have to understand pattern. Okay, if I print it on the screen, so which pixel should be left blank and which pixels should be printed with some color. So here hash is some color, and these blue underscores which I wrote, this is some sort of spaces. So once you understood this pattern, now you'll have to see in each row what I have to print. So in each row, like for the first iteration, we'll have 2 spaces and 1 star, and then 1 space and 3 stars, and then no space and 5 stars. Okay, this is how you will dissect the pattern. Once you understand this, then you will probably understand, once you understand this, then you will have to understand the loops better so as to accompany this task. I hope that answer was clear. Is it? Arshan, Anwar, Liaquat, everybody clear with this? If you see a pattern like this, how to think about it? So here rather this takes your thinking rather than just printing. Don't experiment with, just think it. If I have to print something on the screen, how should it look like? And understand the pattern first. After that, once you have the grip of loops, you will be easily able to do this. And people are making complex patterns by using this. So you just need to understand the pattern and just make a grid like this and see how many space and how many these stars or how many hashes do you want to print in the each row. So Arshan has a question. Can you please show? I can't read the question again. It went somewhere. Let's. Can you please show the code for Mahmood's example? I can't figure out. So don't you see the code over here? I just want Mahmood just asked the question that how to think about these patterns. So his question was more generic, not a particular pattern. So I just gave a generic answer for the patterns, and I just do the example of this triangle. Okay, can I move ahead? Okay, have this is clear. So this was the nesting the loops. So now you can do a lot of things by using these. So another thing I'll show you how to iterate over the tuples. Now we'll do it in the Pythonic way. So Python gives you, again, you can iterate through multiple things at a time. So what I mean by that is, just let's hide this VS Code and let's go into that. So now if you see that we have this for loop. So for we have this iterable I, and we have this iterator, and we have a keyword in here. So this, sorry, this is iterable, and this is iterator. So now if you have a tuple or a dictionary, I think we had discussion on this also. So I just wanted to show you this. So if you have a tuple like this, let's suppose you have say 1, 2, 3, 4, something like this, or you have a dictionary where you have these key value pairs, key, and then we have a value, and then we have key and value, something like this. So in the previous session we saw how to basically iterate toward these things. Now what we can have is we can have a list in which we can have these tuples. Or let's suppose we'll have this. That's also an iterable. If we have a list like this, Okay, in each list we have something like this, and each element of a list is a tuple. This is, let's suppose, 1 comma 2, this is, let's suppose, 3 comma 4. Okay, we can also use for loops to go through these. So if I just write the code over here so as to make it more simpler to understand, so let's comment this code out. So now let's suppose we'll create a list, let's call it L, and then this list contains these tuples inside. So 1 comma 2 is the first element. Let's suppose we have 3 comma 4. Okay, and we can also iterate through this. Now how I can write, I'll write for, let's suppose, I in, I'll call it L, and then let's say I'll print this, print I. So what do you expect? What should get printed? What do you expect? Anyone? What do you expect that what should be printed on the screen?
It will print 1 comma 2 and 3 comma 4.
So if I just press it, you can see that it printed it printed the whole tuple. Okay. Now what I want to do is I basically want these elements separately. So Pythonic way of doing this is I can write two iterators here. So what I can do is I can write a comma b, let's say a comma b in L, and I can just print a comma b. Now what will happen is it will again what you call, it will unzip it. So if you have this list, it will go to the first element. It sees inside this first element of the list there's a tuple which contains two elements. So it will assign one to this A and two to this B in the first in the first of this list when it takes this first element of the list. When it takes the second element of the list, what will it do? It will again unzip it. It will take this 3, it will take it 4, and it will assign it to A and B, and we can print like this. And nothing like this is possible in Java or C or C++. You cannot do something like, you cannot do multiple assignment at the same time. You cannot unzip these things. Okay, now let's see, and you can see this, it printed 1, 2, 3, 4. So right now here it printed the whole tuple. So here I wanted them separately so that I can have the whole of all variables inside. Okay, let's now write like this. So now you saw this, I have 1, 2, comma 3, 4. Now what if I had tuple of different length? What do you expect? If I had, let's suppose, 4, comma 5, comma 6. Okay, you know, if I just write it like this, it will give me the tuple. So what I'm doing, I'm just writing A, comma B. So what will be done? So what do you expect should get printed on the screen?
1 comma 2, 3 comma 4, and 4 comma 5 common if we, yes.
We have just A and B over here. So will it be a syntax error? C. So what do you think?
I think yes, it will throw an error.
Okay, let's do it. It won't throw any. You can see over here. Let's suppose. So this, and it has too many values. So this is that thing. Now what we do is, that's called there's a particular word for this. So there is a word. What we want is, so we want something called as wildcards. So you can remember this word. So wildcards basically tell us, okay, if there are more arguments, if there are these more values to unpack, so we can just write a wildcard. So wildcard starts with the star. You can just print star. Let's see. So C will have all the elements that I want. So I can write comma C. So now this is how we solve the problem. So what we have is, we have this 1, 2, 3, 4, 4, 4, 5, 6. Okay, I'll just not have this repeating pattern. I'll have 5, I'll have 6, I'll have 7. Okay, and now let's suppose I'll increase again the length. I'll have 8, and then 9, 10, 11, 12. So what I did is, here is I put a wildcard in here. So A will first take the first value, B will take the second value. So whatever is after that, so it will be given to the C. So if I just print it, should work. So if you see like this, so 1, 2, then the C basically wildcard is empty first. Basically this wildcard gives a list. Okay, and then if you see this 8, 9, because we have this just ABC, and C takes all the elements that didn't get assigned to this 8, 9, and then we'll have all this 10, 11, 12 as a list. So this is called as a wildcard. So I'll probably write it. So this over here, which I printed with star. So probably it might be new for most of you. So this is called as wildcard. So this star C over here. Okay, if you are just unzipping these things, and you have this variable length, so what you do is, maybe let's suppose only first two elements are important, and then the rest you want to keep in the list somewhere safe. So that's how you do it. And you can only use this wildcard once. So you can only use it in the loop once. So if you want to do it, you just have to do it once. So it can be placed anywhere. It can be placed at the first, at the end, so wherever you want. Let's suppose this, you can place it at the end, at the first, like this. You can write star C, something like this. So I want to print C first, then A and B. So if I just now print it, you can see this, the wildcard is first, and then we got 1, 2. Okay, basically it does the thing in reverse. So it will take the last elements, as it took 11, 12 for this A and B, and for this 8, 9, and 10, it made a list and assigned it to the C. C basically returns a list. So this is called as the wildcard. And you can what I call unroll or unzip like this. And you can do it with the dictionaries, or you can do it with tuples list if you have list among the list and something like that. I hope this is clear. I'll conclude my discussion of the for over here. So there are a lot of things that we can study for, but for the basics of for, I'll just start discussing the for here. Now we'll go to the while loop. The first question, natural question, should be, if there is a for loop, then what is the need of while loop? That's the first natural question to ask. Okay, now we'll go to while loop. So this question should be there. So whenever I'm teaching something, so you can probably ask me, okay, if there, I told you we had multiple statements in conditionals. We had if else, if else later, and there is one more thing called as match. Okay, I didn't touch that, and we have the tertiary operators to make this succinct way of representing if and else. But here, if you see that for loop is able to loop. Okay, the main thing that we want. If you see the programming construct, so if I can make a map before discussing the loop, please be careful about try to understand this map. So what we had, the first thing is we had some data and we want to manipulate it so that we can perform certain tasks. By manipulation, we should have certain operations. So that's for this data. So on top of that, we should have some operations. We should have some manipulation power. We should have some manipulation power to do to attain certain to achieve certain tasks. So that's what mathematics does. We'll create a set of language. So this data basically is a language or maybe representation of something. So rather than data, I'll write representation. So we want a representation. Let's suppose we want to understand the world. So for that, the first thing is we want a representation. So by using representation, we discovered data types. So we said, okay, now in our whole world of mathematics, let's suppose we want, if we want to compute something, what is computable? That's why I asked the question in the first session. So what is computable even? What is the meaning of computation? So there we answered these questions. So for computation, we came up with these symbols first. Okay, we developed a language, an abstract language, maybe of symbols and maybe of numerals. So we said there should be different data types. There should be English and there should be these numbers where we manipulate these. And on the manipulation, we studied operations. Okay, so we had data, and on top of that, now we have these operations. We can perform operations, and we also now see that in programming it just ran top to bottom. The code was executed line by line. So for that we said, okay, if I want a control, if I want some control, so for that we invented control flow. So what kind of control do you want? I want two types of control. I should somehow be able to branch, because I don't want to run directly from top to bottom. I don't want to execute just line by line from top to bottom. I should have power so that I can branch somewhere if I have some conditions to meet. So I should have the power of branching. I should have some conditions. If some condition is met, and based on that, I'll probably deviate from the actual flow. And that was one of the control flows. And then we should have the second thing is I should have possibility of looping things. I should have possibility of iterating things, doing things repeatedly. So in the control flow, we came up with these conditionals, and then we came up with these iterations. If you see this is the world that we are in. Okay, and now the question, I told you that there are multiple ways of branching the things, and I gave the rational reason. So if there is only if, we can achieve the things, but if and else make it easy. Okay, and if you have to construct a language, so basically these are the basic building blocks that you'll need. So you need a representation of numbers. That's why the initial step towards language is to understand how this language is storing data. So how is it storing data? Okay, so it gives you different data types. So Python gives you a humongous number of data types. You saw lists, you saw these integers, floats, in numerals, and you saw these tuples, dictionaries, you saw these maps, and there are a lot of data types that Python gives you. And then on each data type, there were operations that we defined. So let's suppose if you have a string, there was operation of slicing, there was operation of indexing, and there was operation of concatenating, there was operation of, let's suppose, some other operations were defined. And similarly on the numbers, let's suppose we have integers, we had a concept of arithmetic operators, and we learned about a lot of operations. What can be done on arithmetic numbers, what can be done on basically these numerals, integers or floats. And then we also studied about relational operators and bitwise operators, and based on these we saw we had a data type, and we had a set of operations that are possible on that. That's what the world tells us. If you want to do something, we should have a representation. If you have a representation, after that you want to manipulate things. Okay, so representation is what is data types, and the manipulation is what operations you perform so that we want some results. And then now the third step that we had is we want to have some control of the program. So now we know that the flow goes from top to bottom. It goes to line by line. So, but the most important thing that we wanted is we wanted to control this flow somehow. It should not go just line by line in just specified direction, but we wanted to somehow branch the thing. That's why we came up with this branching and loops. Is this map at least clear how programming language should are developed? You should not think like programming language to be okay. You just need something. These are loops. This is very important. This is very important to understand. If you want to become really great programmers, this thing should be like sort of printed into your head. Okay, we had a representation of the things. That's the data. That's the world we have, and now we want to manipulate the data. Okay, that's why whole of this is based on maths. Okay, so this whole thing is called the programming language are based on what's called as lambda calculus. Okay, so this is the underneath mathematical framework that the programming languages are based on. Okay, and I think more or less if you know, if you understood these things, if you now know the basic data types are nothing but representations, operations are nothing but manipulations that we want to do on the data, and this control is nothing, we just wanted to somehow branch or somehow wanted to loop things, and this is all that programming is about. Now everything that I'll teach after this, after we are done with this, so we'll basically try to write modular code, try to write better code, and try to write code in a good style so that the other people who are reading it, or if you want to reuse the code, that look better. But if you have this, if you know these steps, and these are all basics in all programming languages. So if you want to develop your own language, you should first have a discussion. Let's suppose you have multiple inventors, you'll have discussion on this. What data types to give? What operations to give? Okay, how should we implement the control? And how should we implement this branching? And how should we implement loop? And in the Python, if you saw that we have if else, and then we have this if elif later, and then we had this match. Okay, and these were the ways in which we control the flow, in which we control the basically flow of the code, and if we want to branch. And then the loops, I said we have this for loop, and for loop can achieve many tasks. And but I told you that we have this while loop. Now we have this while loop. The first natural question I told you is that why are these so many stuff? What is this loop while loop for? So what is the thing that for loop probably can't do? I'll say not can't do, it will do, but it'll be tedious. It can do it, but you'll have to put an extra effort. So for that, we'll introduce while loop. So for loop is sometimes called as a definite loop. Again, my whole basically assumption here is I don't teach you per se only Python. I'm teaching you art of programming. So this is the art of programming that I want to teach you. And then I'll just use Pythonic syntax. So this is what Python, this is how Python does it, and I'll probably show you the examples in Python. And once you go into other language, and if you have solid grounding in these things, and I'm pretty much sure that you will pick up any language not in more than 6-7 days if you have solid grounding in these things. That's why I just am giving you the whole context, the language first, and after that I'm just introducing Python syntax. I could have done this with C, C++, Java, R, whatever, Julia, whatever language we can choose, but here the Python is of choice because we have a community support here. And after that, it'll take you practice. So what I said is for loop is called as definite loop, definite loops, or definite iterations, and this is called as indefinite loop. Probably I have seen many books who have not written these sort of things, and they are really important to understand. So from a programmer's perspective, because I told you in the session that we'll try to rediscover things. Okay, if I was a programmer, if I was the inventor of this language, how will I sort of create the language? You should have that sense once you read these structure, once you read these all these programming lingo. So for loop is something called definite loop. Why is it so? Because definite loop here we know how many times we want to do something. If you saw, let's suppose we had a list, we knew that we will iterate through whole the list. Once the list is exhausted, we want to do nothing. So here, upfront we knew what we are going to do, how many things that we want to print, or how many things we want to manipulate. So that's what this is called as definite loop. Okay, upfront we knew how many times. Okay, how many times we want to do something. That's what for loop does. So if you know upfront, okay, I want to do something these many times, so you'll use for loop. Okay, that's why it's called definite loop. Why? Because there is this definite nature. Okay, you want to do if there are 5 elements in a list, and once the list gets exhausted, I'm done. I won't do anything. I want to run this loop 5 times. But sometimes you don't know how many times I want to basically do a certain task. Let's take an example. If you are prompting a user, okay, let's say we are making that personal finance manager, and you want to ask the person, okay, can you give me the income source one? You know that income cannot be negative. So you want to prompt it again and again. If let's suppose user made some mistake, it printed some negative number. Okay, you want again prompt it, and you don't know how many times user will enter the negative number, or how many times user will make the mistake. And in that sense, you don't know how many times the loop should run. So this is some sort of indefinite. There is indefinite nature of the loop. Okay, till the user prints the right number, till the user prints the positive number, you'll keep on popping the user. Okay, what's your income, what's your income, what's your income? Let's suppose he prints minus 10,000 and he's, let's suppose, like most of these poor scholars, he'll say my account balance is, let's suppose, minus 2,000. I have taken a loan. So what will happen? Because you don't accept negative balance in our natural thing, we don't accept that a philosopher is poor. We'll say no, no, show us positive balance, and we want to continuously do it till the point we get a positive balance. Okay, and now you see this, there is indefinite nature of the loop. If you have this thing, if you have this requirement, so that time you will use a while loop. So is the difference between for loop and while loop clear? Why are these two programming constructs defined the way they are defined? Because for loop, if you have definite iterations, definite number of iterations, and you often know sometimes that these many iterations I'll do, and in while loop you don't know how many times I'll have to do it. And if a certain condition is met, and then only I'll break out of the loop. I'm saying that I won't iterate anymore because my condition is met. So here, what you, in the for loop, what you are saying is sometimes you have this definite nature. You know how many times the iterations is to be done, and that's how you will use for loop, and that's where you will use the while loop. While use is there when you have this indefinite nature. If I till you don't know, okay, what will be, how many times the loop should run, and in the for loop, most of the times you know it. Is it clear? Any questions? So now I was talking about while loop. The first thing that I want to teach you in the while loop is the syntax of the while loop, how the while loop looks like. So if you see, I'll just comment out this code. Okay, I'll comment this out, and I'll create some new file. Code. I'll create test.1. Let's clear this. I'm going to make sure that this is running. Yes. So how is the syntax? So while loop has this syntax that I'll paste on the screen. So this is a syntax. So you can see that we have this while, and then we have an expression. So this expression again should give us some Boolean answer. Okay, because you understood now that Boolean is again a data type. We can get true or false. Okay, and then we have these statements. And again, take care of these indentations, because whatever is indented, that only will execute in the while. Okay, and this expression, make sure that this gives the answer as Boolean. Okay, while, then expression and statement. How this runs is like this. So till this condition gives value false. Once it gives false, this statement won't be executed. And if it gives true answer, this statement will be executed. Okay, continuously. So let's do an example so as to do it. Let's suppose I want to say print hello some number of times. So what I can do is I can just take a variable count. Okay, count. I can do it in multiple ways. So I'll just show you one way. Count is equal 0. Let's say. So this is the count I want to print it these many number of times. Or maybe we can start with, let's suppose I want to print it 3 times. Count 3. So I'll write while, and then I'll write an expression. Okay, this expression should return me the Boolean. So what returns the Boolean? So relational operators. If you see the operators which are relational, they'll return the Boolean values. So I'll say count is, let's suppose, less than, while the count is say greater than 0, or maybe less than, greater or equal to 0. Okay, and print this. So what should I print? I should print, let's suppose, hello. People who know the answer should not give me the answer. Maybe people who are doubtful. So how many times do you expect this loop to run? Maybe Anwar, if you can give the answer, or maybe Arshan. So what should get printed on the screen? Any answers? So I said like till the condition is met, and it should print this hello. So this is the body of the while loop.
I think it will print infinite.
Yes. Why is it so?
Because count is 3 and it's static.
And we're not changing the count. Yes, it's continuous. So if you see that, the thing that we have here is we never do anything with the count. So this should get to the infinite loop. That's why we call it sometimes as infinite loop. So let's suppose we run it, and you will see it is printing hello continuously. So if I want to stop it, I'll just print Control C. This is how I'll stop it. I'll make a keyboard. It's called as keyboard interrupt. Okay, so what should I do then? Okay, in each iteration I should decrement the count. I should say count, okay, is equal to count minus 1. I should do this. Now if you see it, if I run the code, so in the first iteration, if you see this, so let's dry run the code. Dry run means count was 3. Okay, so count is greater or equal to 0. This condition was true. It will print hello. So the hello will get printed first. So this is hello over here. Okay, and then I am decrementing the count. So this 3 will become 2. And now while count is greater than or equal to 0, again it is greater, this will return true. Print hello, it will again print hello over here. Okay, and now the count is again decrement, count will become 1. Okay, and now again it will go count greater than or equal to 0, it will again return true, it will again print hello. Again we'll decrement the counter, so this will become 0. Now it is 0, again I have put equal to, greater or equal to, it will still be true, this condition is true, it will again print hello. Okay, and then count will be decremented, and this will now get to -1. Once this is -1, now the count, this value, this expression will return false, and now it will halt the loop, it will go outside the loop, it will not run anything. Okay, and now we saw that 4 times the loop will run hello. Let's see this in the code. So if I just run this, you can see hello, 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 and hello, 4 times it got printed. So now you saw this indefinite nature. Okay, so let's suppose I was giving you the example of that. So let's here, at least I knew that I have to print this 3 times. Let's suppose I want something like this. I want while true. Okay, I'm saying that what is your income? Income, let's suppose, is int. Okay, int input. Let's suppose enter your income. So what I'm saying is, till you don't give me a positive number. So there are different ways to just do it. I'll just show you one. So I'll say print end of loop. I'll write it here. End of loop. So now I put it in an infinite loop because I don't know how many times user will print a wrong, because I don't want negative number. So what I'll do is I'll say if income is less than 0 or greater than 0. Once it is greater or equal to greater than 0, because we want a positive income, then only break out the loop. Otherwise keep looping. Okay, and then we'll show end the loop. So let's suppose, because now we don't know how many times the user will create a mistake. So let's suppose now we'll print, we'll just test this, enter the income. Let's suppose he wrote -60. Enter the income, because this is not the right number. So let's suppose we write -500. Enter your income. Let's suppose we write 0. No, enter your income. Once I enter the positive income, then only the loop will be broken down. So if I write 500, now you can see end the loop. Now use the indefinite nature of the loop, because I don't know how many times upfront, I don't know how many times the user will create mistake. So I am putting it in infinite loop, and once a condition is met, then I'm breaking out of the loop. And this is the typical example that I wanted to show you. If why do you want to use this while loop? So you can achieve the same thing using the for loop, but the code will be a bit tedious. You'll have to write more lines of code, but you can still achieve this. But this is a simplistic version how you can use the indefiniteness of this while loop. Is it clear? I hope this is clear. Now, in the similar way, what you can do is you can use while loop with these lists maybe, and you can use this. Let's say we'll use this while loop in the list. Let's suppose we have a list. Okay, let's just comment out this code, and we have a list. Call it A. Let's suppose A has these numbers 1, 2, 3, 4, 5. Some numbers like this. Okay, what I'll do is I'll say just pop the elements. I'll keep on popping the elements till the list is empty. So I can write while there are elements in A, while A does not return me none. Okay, while A, what you should do is print A dot pop. So you know that list has this function pop. Pop basically means remove that element from this, the basically topmost element, remove it from this. So we'll see what gets printed. So you see that topmost element was 5, it removed it first, and the list remained, and we can print the list also. Print what was list. So print list, print A. So initially if you see list was 1, 2, 3, 4, 5. List first was 1, 2, 3, 4, 5. Then you popped out this element. You removed the element 5. Then you can see that list was down to 1, 2, 3, 4. And then you removed this 4. And then you had 1, 2, 3, 4. And then you removed this 3. You had 1, 2, and then 2, 1. And at the end, once the list became empty, so this condition became false. So this A, there was nothing in the list, and we just kept on popping until the list became empty. This is how you can also use while loop. And sometimes again, if you want to pop and you don't know how many elements in the list, so otherwise in the for loop, the first thing you'll have to call a function. Okay, length of the list. What is the length of the list? These many times run the loop and pop these many elements. So there is that definite nature you want. You want to know upfront how many elements are there. Okay, so best part is that you don't want to create the length function. You use this while loop till the list becomes empty. Just pop out the elements. Is it clear? Is it clear so far? So this is the while loop and the for loop. I hope that these two loops were clear, and the main difference that I showed you was the definiteness and the indefiniteness. And as Mahmood pointed out rightly, whatever you can achieve by the while loop, you can also achieve by the for loop. But sometimes it becomes tedious or it becomes difficult to write, and it's better that you know where to use what. So you can use while loop when you saw that there is some indefinite nature, and you can use this for loop, and where you see this definite nature, and you can also intermingle them. Sometimes you feel okay, the while loop can do it better. If I write in a Pythonic way, it will be better and it will be understandable, because you are not writing codes only for the machines. At the end, you are writing code for the machines, but internally, when you work with the team, you are writing code for the humans also, who will read the code. Okay, and there is one more thing that I wanted to tell you. That is very important in the programming. It's difficult to find the books. That's why I'm taking more time to explain this. So these are very small things, but these become very good if you know them and once you code in the team. So let's suppose what I did is I want to print something 3 times. So I'll say for I in a range of 3. So range of 3. So print hello. Okay. So if I print it, you know that the print will get printed 3 times. But you saw that this I was never used. Okay. This I was never used anywhere. Okay. I could have used this I also. Let's suppose I could have used this I comma. Okay. So if I just run it, so it will print 0 1, it will print 0 1 2 and 3. If this I is not used, and many of the times you won't use these iterable, so what you do is, in the Pythonic way of doing it, you will just put an underscore, so that the programmer knows that this underscore is not used anywhere. So whenever you are not using the iterator by which you iterate this variable, if you are not using it, so the best way to do it, you just put an underscore. So this gives the programmer that message that this variable is just for iterating. This is not used anywhere. I am not using it anywhere, so better just put it here. So if I write it, the same thing will be achieved if you see it. So I got printed hello, hello, and hello. So as we had this initially, but this as I was not used, so it is better to just write the underscore. If you see the big open source codes, and you will find the loops written like this. So if you see this symbol written in the loop, know that this variable is not used anywhere. And the good program practices, you will write these variable names so that it is understandable. Let's suppose you have a list of names. I'll create a list in which I have name of students. Let's create a name of students. This is how you should give the names. Students, and then let's suppose the student we have is Mahmood, Ijaz, and let's suppose we have Anwar, we have Arshan. Sorry if I missed somebody. So we have other students also. So for this, what you can do now, you can see that the naming convention I use students. So now if I want to iterate through all of this, what I can do is I can write for dash, no, instead of dash I'll write for student. So this is now a meaningful way of writing it. So when you write this code in this way, so it becomes easy for the other programmers to read it. For student in students. Okay, the students is a list, this one is a list, and this contains each item in the list, and then print, and you want to print students. You want to print the student. So if I do this, if I run the code, you can see that Mahmood, Ijaz, Anwar, Arshan, they got printed. Okay, and now this is very meaningful. I have seen people writing for I in this and then print I. It is good. It will work as expected. But remember that you are not writing just code for the machines. You are writing code for the humans also. So it should be human readable. One more thing I wanted to show you over here is, so these things are indexed also. So if you see list is an indexed thing. Okay, you can index the list. Okay, so now you can use that indexed variable. So if I just write the range and I just want to get indexing. So for, let's suppose I'll write I in a range of how many students are there. What I can do, I can call length of list. So length of students. Okay, and then what I'll print is I'll print I students of I. This is the way of it'll again print the same thing. That's students. I think this is the mistake. Yes, hopefully an error. So good. So now if you see this, so this is the indexed way of doing it. So now let me explain this again. I hope that everybody understands this. For the sake of completion, I'll explain this. So if you see students, here is a list. This is indexed by 1. This is 0. This is 1. This is 2, and this is 3. So what I did is I created an indexed variable. That's I. That's why in for loops we use I. I means index. So if you have seen this, we always use this I, J, K. I basically meant index, and then we had nothing to use. We said, okay, we'll use J and K also. So I is for the it stands for index. So then range of length of students. This length of students, it basically gives me how much length it has. It will give me 4. If I just run this length of students, it will give me 4 over here. For I in range of 4, that means I will get value 0, 1, 2, and 3. So print students of I. Go to the students and go to that indexed location. And we have seen how to index this list. You can also use this for loop in this way also. So I have just written this I will basically take this value 0, 1, 2 and 3, and after that it will just index, because student is a list and list is an indexed data type, so we can index it at a certain position. So students of I, that's what we get, the answer is like this. So I hope that this is again clear. So I'll just comment out this code, and if there are questions, I am ready to take the questions again. Now there are some things in the loops, and we want more control in these loops. So what we want is, sometimes we want to skip an iteration, we want to break if a certain condition is met. Okay, so what there are something called as loop control structures. Okay, loop control isolate statements, loop control statements. So now loop itself is a controlling statement, and we are controlling the flow. That's called control flow. Now we want to control the loop itself. So what you want to do is, within the loop, if something happens, you want to do certain thing, okay, and you can use if else everywhere in the loop also. Now there are these loop control statements also, by which you can achieve certain tasks, okay. So they change the normal sequence execution. So if you see that, if I just want to print, let's suppose from 1 to 10, so now what you can see is, you can see 1, 2, 3, 10 got printed. But what if you want to skip, let's suppose number 5, okay, for that we should have control. So we have different statements in the loop control statements. The first statement is break. Okay, then we have continue, then we have pass, and we also have else with the loop. Probably this is again new for many people. So you can also write else with the loop, else with for loop. So this is with for loop, else with for loop. Okay, so these are the loop control statements by which you can control the execution of the loop within itself. So if you have a certain condition, you want to do that, you can break, you can continue, and we'll see what each statement means. So these are the 4 loop control statements. Break is there, continue is there, pass is there, and else with the for loop. Else is only specific for the for loop. So now let's take each statement one by one. First we'll start with the break. So what break does is, let's suppose you are running a loop, okay, and if a certain thing is done, let's suppose you are sure that this thing happens so rarely, but if it happens, just break out of the loop. Okay, as we did, I think I just used break in the before some time. So you want to break out the loop, and let's suppose you have some list of numbers. You have 1, 2, 3, 4. You have a list. Okay, you want to see if any time I saw this 3, I'll break out the loop. I won't do anything. Okay, because you expect this number should not be there. You'll break out the loop, or you'll have different requirements. Okay, what break does is, it'll take you immediately out of the loop. It won't do all the iterations. Then let's suppose in normally if I run a loop on this, let's suppose it's a list, say it's a list, I want to run this loop, it'll normally run for 5. It'll first use this 1, 2, 3 and 4 and 5. But what I see is, if I have this 3, okay, if I have this 3, I'll just break out of this. Let me give a physical example. If you are searching something, in the list, so what you can do is, and if you are searching for, let's suppose this 4, or let's suppose this for a 3, and once the search is complete, because if I found the element, I don't need to take care of the rest of the elements. I won't look at them. I won't look at the other elements. So that's why break is important. Say you are searching this element 4. So what you can do is, you can traverse through all this list. You can say 1 is not equal to 4, 2 is not equal to 4, 3 is not. Once you see this 4, so what will happen is, you want to break out of the loop, because there may be millions of elements afterwards, because your job is done. So I'll just come out of the loop. If I found this 4 in there, that's my job, and irrespective of how many elements are there. So that's just one example where you can use the break. So if a certain specific condition is met, whatever you want to achieve, that is done, and you want to run this loop no longer. So what will happen? You want to come out of the loop. You'll use this break statement. Okay, let's go to VS Code to show it. Just making this new test.2, test2.py, and closing this test1. Yes. So I hope that let me paste something on this. So here, if you see, for I in range of 5, so what I'm doing here is, till 5 run it. If I don't have this statement, so what I'm doing is, I'm putting an expression over here. If a certain condition is met, so you see that this break is usually written with if. If a certain condition is met, you will break the thing and it won't run anything. So you'll see this first print I basically means 0, 1, 2, and once the 3 gets 3 is printed, and it'll come out of the loop. So I'll say here, out of loop, print out of the loop. Let's suppose this was not there. So I'll just comment out this portion of the code. If this was not there, usually what's the flow? The flow is 0, 1, 2, 3 and 4, and out the loop. It did all the execution that it was expected, and it after that just skip it, and it completed the loop and came to this print out of the loop, and it printed that. So now what I want is, if a certain condition is met, as I just showed you the example of searching, if you are searching for an element, if the element is found, you no longer want to search more. Let's suppose you have million records and you just found the element at the second place. You don't want to search for all million minus 2 records. Okay, that will be again tedious. So for that you will use this break statement. So if I just uncomment this code, so I'll say if I is equal to 3, so it will break. It won't run after this. So the expected output is 0, 1, 2, and at 3 it will break, it will come out of the loop. So you can see this 0, 1, 2, and the loop broke at I is equal to 3. That's what got printed over here. Okay, and we are out of the loop, and that's what break does. So break loops this break statement, and within the, if you write it within the loop, if a certain condition is met, will immediately come out of this loop. Okay, and on meeting the certain condition. Then there is the second statement which is called as continue. Is the break clear for everyone? Any questions on break? Okay, now let's have this statement which is called as continue. Continue. So continue basically means skip a thing. So let's suppose think it like this. So let's suppose there is some meal is being getting served. So you are there, you are as a guest, and meal is getting served, and you don't want to eat a certain thing. So you can just say continue. And you when the let's suppose when a chef reads at your plate, and you will say continue. By continue you mean don't put it here. You can continue to the other things. So what break was doing is, so if you were at that, you were saying I will not eat this. Nobody should eat this. Once you reach there, or that means exhaust, or don't give it to anybody. But once you are at that continue. So what you are saying is, I won't prefer to eat it, but give it rest. That's what continue means. So skip me. Again, this is again with this condition. If a certain condition is met, and I want to skip it. Okay, and I want to skip that thing, and I want to do the these blocks a loop again, but for the particular condition I want to do it. So that's why this continue is used for. So continue basically means you should skip the things. Let us use the skipping first. Again, it'll have the same syntax. Let me show you the syntax. Coming to the VS Code. So here, if you see, I'll just comment out this code. So I'm writing for I in range of 5. If I is equal to 2, skip it. So what is the expectation? So if you don't have this, let's suppose you don't have it. So at that time, what should happen? 0 to 5 should get printed as expected. You see that this the output. If you see the output, so the output was skipping iteration at 2 because I did not save it. I told you to look at this. At the top of VS Code, you have this star because I did not save it. I'll save it first and then I'll run it. The output is 0, 1, 2, 3, and 4. Now what I want to do, I want to skip at 2. I don't want to print this I is equal to. I'll just even write this skip statement. I'll print. So if I just run it now, so it will say 0, 1 at 2. I skipped the iteration. It's like something was getting served to everybody. 2 doesn't want that, and at 2 we said continue. Continue means don't serve me this thing, serve it to others. Okay, but what break did? Break said break it here. Okay, you have to serve till only here and don't go beyond this. Okay, that is a mental picture you should have about this break and skip. Break basically means if a thing is getting served or if a thing is getting traversed until a point, if a condition is reached, break, nothing will get served after that. And in this continue, what you will do is you will basically say continue. That's why it makes sense. Continue. Continue means skip this thing and after that continue the iterations. Okay, that's why it's called continue. Continue the iterations, but accept this. Okay, that's what you can see over here. 0, 1, 2, 3, 4, and rest. We did this. So what I can say is, let's suppose I'll write a brief program over here. So I'll say I'll have a string AML class is going on. So we have this AML class which is going on. But what I want to do is I want to print all the letters, but except this E and S. So there will be AIML classes is going on. AIML class is going on. So this will be a string. So in this string, what I want to do is I'll print all the letters except for E and S. Okay, I want to continue in that. How to do that? So if you see it over here, so I'm saying at I is equal to 0. Okay, so AIML, this is the string. AIML class is going on. So I'm saying while I is length of A, till this there is this length, some length is met. Okay, there is this length. I'll get the value I, and this I is basically length of A. If A of I is equal to E, or this. Okay, if you see I have just contained with or some operations, or it's S. Just skip this and put I plus 1 and continue and just move to the next iteration. So here if you see this I will start from 0 till length of A. Length of A basically means what are the length is in total. But here I want to skip this and I want to continue. Okay, if I run this, so you can just see it. So the current letter is AIML. I'm skipping the letter E and S, so you won't find E and S anywhere. The important thing that I wanted to show you here, this whole expression should be boolean again. It should give me the answer. Let's suppose if this is if this condition is this is an expression. Once it gets evaluated, it should be true and false. If it is false, this nothing will get executed. So if this is true, then these things will execute and it will continue to skip the iteration. So yeah, that's why you can see this E and S did not get printed because we have this class. So it got A I M L C L A. Then SS is not printed. Then I am then we have see this is and then there was S. S is again not printed and we are skipping this. Look at this code and try to absorb the code, okay, and see how I have used sort of not much complex, but I have used some other operators, some logical operators within that. But the whole point is that this if should have an expression which should give me the boolean as an output, okay, and also make sure that you again map why is this I plus 1 written over here, because I'm starting this I with 0 and it should go till length of a, that means howsoever the length of this is. Okay, we can do the same one more example for a break. So let's suppose if I see E or S, so I'll say Alhamdulillah for the guidance. Let's suppose I'll write a string Alhamdulillah for the guidance, and if I see a letter, let's suppose E or S, so I'll break. Okay, so if you see string, again more or less the same code, but there is break. So what should get printed? Once I see the E or if I see the S, it should get break. So it should get printed till here, because I want to see E or S. So if you see, is there some S? E is over here, I think. So let's print it. I don't want to manually go through all the lines. So Alhamdulillah for the, and you see E is over here. THE and E is over, we broke and nothing got printed. So this is what break and continue does. So break comes out of the loop immediately and continue. Just say skip this iteration and continue the other things. Okay, skip this particular iteration and then continue. Do you have any questions on this break or on this So the question here is if we have nested loops, we can have nested for loop, nested while loops. So in that, if you put a break statement, the break statement will be will execute it for the loop for the loop in which it is in the body. Let's suppose you have this multiple for loops and break is in the inner loop. I'll write a code. Let's say something like this: for I in a range of, let's say, 4, and then for I in a range of say 6, something like this, and you can say print, say hello. Oh, let me print hello, and then what you are saying is you can also put an if statement before this. Let me put an if let me put this j, if j is equal to break. So now if you see, this break is under this for loop. So if you see the indentation clearly over here, so this is part of the inner loop, so it will just break the inner loop. So outer loop, it won't have an effect on the outer loop. So let's run this code and I'll show you this. Basically I should also print let's suppose I comma j and this hello, so that it becomes clear. So now if you see 0 0 hello, 0 1 hello, 1 0 hello, now once it is 2, you can see that it broke the loop. You can see we'll expect for 0 1 0 1, then we should have 0 2 also, but it's not there. Then we should have 0, it broke the loop, it broke the inner loop, but again it started the outer loop. Outer loop started 1. So for the outer loop it ranges from 0 to 4. That's why you can see 0 till 3, that's 0 1 2 and 3. But for the inner loop it only goes to 0 1 0 1 0 1 0 1. So now it tells us that wherever the break is, whichever the break whichever for loop the break contains, okay, some body of the for loop will contain this break, and for that particular loop this will basically break the flow. Okay, for in this particular case the break is basically for the inner loop. That's why it's printing only. If I write this 3, so what should happen is I will anyway run. So I will have this I 0 to 0 1 2 and 3, and now it for each of this I, this will only run for 0 1 and 2. If I just run it, you can clearly see it. For 0 it ran 0 1 and 2. Once it became 3, we broke out the inner loop and we came to the outer loop again and we start with 1. If this was not there, okay, now if this was not there, everything will get printed. Okay, you see this 0 0 0 for 0, this 0 1 2 3 4, this is I and this is j. Okay, and again for I, for all the ones we get 0 1 2 3 4 5, and then for 2 0 1 2 3 4 5. And see, just remember the tree diagram. So that tree diagram was like this. So we had this, oh sorry, we had this I, okay, and then we had this j. And when I was 0, this was I was 0, and then it ran for 0 1 2 3 4 and 5, something like this. Okay, that's what is showing over here for these 0 0 1 2 3 4 5. But once I put that break inside, and you can clearly see that this break it took the control out of this inner loop, not for the outer loop. That's why you should be careful about the indentation. Okay, if I write the break like this, let's suppose if I just commented out, okay, and I write, let's suppose I'll cut it, and this is the indentation is for this loop. If j is equal to break, now it will break the outer loop and it will just stop, because inner loop will not depending on the inner loop, because inner loop is again in the body of the outer loop. Once the break is seen, what will print it? So let's suppose it will say for I in range of 4, for j in range of 6, print hello. 0, and it will correspondingly print 1 2 3 4 5 and all the hellos, and again for 1 it will print 0 1 2 3 4 5 all the hellos, and once it reaches the 2 it will break, and after that it will print nothing. So basically it will start with this 0, it will print this, it will print this 1, it will only print this much, the highlighted one over here. So if I just do this, so you can see it over here. So 0 and 0 1 2 3, and we had this if j is equal to. So is there some mistake? No, it is not. There's no mistake probably. So I'll just say this again. I don't know, it is. So if you want to write on the code, so what you can do is, so I'll write on the code like this. So let's just remove this. So for I in range of 4, so first we'll have the I is equal, and sorry, it is j is equal to, it should be I rather. So sorry. So this is what the expected output I wanted to write on it, and now you can see this. That's what you should be careful about, what you are breaking the things at. So for 0 it will run all the hellos, for 1 it will run all the hellos, okay, and then if I is equal to, and then break out of it. But what happened actually is the break statement is written after this, after the inner loop is getting printed after this. That's why it will basically break at 3. If I write this break at right here, this is really good. I am getting to show you all of these things, because sometimes the where you place the statement is also important. So if you see in this screen, so 0 1 and 2 also got printed, because after that we broke, because we were running the loop first then breaking. So now I just changed the statement. So what will happen is the 0 and 1 will get printed, at 2 it will break, because it's first checking for the condition then running the inner loop. So if you now see this, now it broke at 2. This makes more sense. Okay, that's why the place in the statement is also important. Where to place this? So are you running loop first, or are you running this break statement after? So in the first go, what I was doing is I was running the loop first, and after that I was running the break statement. So that's the reason we got this thing as printed. We got this 2 also. So if you see this, so what we had is we had this all the zeros, then all the 2s again. After that, once it reached here, then it saw, oh, there is a 2, let's break it. So if you see this, zeros, ones, and then 2s will appear. So zeros, then ones, then 2s will also appear, because the break statement is after the for loop. So it also becomes really important where you place these break and continue statements. So if you place, sometimes there will be a mismatch. As I had something in the mind, okay, I want to break it too, but the problem here was I put the statement after this for loop. Okay, but my intention was it should get the loop should get broken down at I is equal to. The problem here was I put this I is equal to after this loop. So it is better to put it before the loop. I hope that this placement of these statements is also very important. You understood that part also. Is there any other question? So I'll stop the recording over here. If you have any questions regarding the session, feel free to ask. I'm just stopping the recording.